Now, this next section, section 2.7, talks about electrical circuits. And those of you who took linear algebra with me, we did some work with electrical circuits. The ones that we talked about there, we're just talking about current flow. We had a battery and we'd have a resistor, and that was it. Okay, and so one of the things that we came up with there was we talked about V equaling I times R, and sometimes V is replaced with E, okay, where E is the electromotive voltage, okay? So E equals IR means the same thing. It's just the amount of voltage. Now, this equation, this terminology is what's used in this book. And they say that's the voltage as it has to do with resistance. But there are more than just resistive circuits or resistive elements in a circuit. There's what's called a capacitor, which for those of you who have had physics with me, you've already talked about capacitors. There are these resistors, and there's what's called an inductor. Now, what a capacitor does is that it is a place where we can store charge. So if we think about charges coming out of a battery here, we have a positive side and a negative side. And as the charges come up here, they want to spread out here because charges don't like each other, etc. So as they get up to this point, they can spread out along this capacitor. This can be called a parallel plate capacitor. Okay, and there's different types of capacitors. But what allows them to do is it allows them to spread out. So they'd rather go up there than be close together along this wire. So they go up to the capacitor and they store. Now, why is a capacitor useful? Well, we get them to store there, and then we can have a switch that goes across here and get the flash all at once, and all that energy dumps at once. If you used a flashlight, you know that the battery is there, and it's constantly putting out, charges that allow you to see. Those charges are running through the light bulb, and they're causing it to glow. But anybody who's used a flashlight versus using a flash camera, or the flash that you have on your phone, the flash on your phone is much brighter. Very brief, but much brighter. Well, a battery will allow you that long discharge over time that you get with a flashlight. But if you want a flash, like you get with a strobe light or with a camera when you take a picture in the dark, you want a capacitor, and you basically just put another piece in the circuit, which is a switch. You charge this up, this opens up, it's sitting there charged, you push the button on your phone or camera, that closes and it flashes through there, okay? So that's the purpose of having a capacitor. In addition to capacitors, we have something called an inductor. The purpose of an inductor is to actually slow down charge, okay? It doesn't limit the charge the way that a resistive element slows or makes the charge go slow, but an inductor just kind of slows the whole process down, and we're talking about over a period of time it makes it go slower. Okay, so for an inductor, and the symbol for an inductor, actually a light bulb is a type of inductor. Okay, that symbol right there is an inductor, and when charge goes through an inductor, it's just slowed down. That whole process of the discharge is slowed down. So it turns out that when you're talking about capacitors, and again, for those of us who have had physics already, we said that the capacitance times the voltage was equal to the total charge. Well, again, replacing that V with E, because that's what this book does, and solving for E, we would get that E, and we'd say E of the capacitor would just be the charge divided by the capacitance. In addition to that, we also have the E based on the inductor, and for the inductor, it actually, how much voltage is used depends on how much current is flowing. So it's dictated by the current. So E of the inductor, the inductance, and then the change in current flow with respect to time. So it's actually a differential equation. So those three things right there, we could have all three of those in a circuit. Here we got our battery, we got a resistor, come up here, we've got a capacitor, we come over here, we've got an inductor. Okay, all of those can be in a circuit, and all together, along with the battery, the total that we see in here of voltage will be equal to 0. If we go all the way around that loop, whatever voltage is produced here will be eaten up here, eaten up here, and eaten up here, and the total, the sum of all the voltage as it goes around, will be 0. So, we're going to do some differential equation. We can see where a differential equation is coming from because of the fact that we've got this guy sitting here.